One website defines cloud computing as a general term for the delivery of hosted services over the net. That is, you have a bunch of services that are hosted over the internet, and many clients across the world can access these these services that are hosted somewhere centrally on the cloud. Welcome everyone to Sysco LABS. So the weather is not very good today, but the crowd is pretty good. So so let's make it as an interactive session as much as possible. So just feel free to barge in and ask any questions. So what I'm going to do during the first session today is going to talk about cloud computing. Of course, that's the main topic today. So I'll be looking at some of the cloud computing aspects, and my colleague Kalinga will be following up with other aspects in the end as well. When you just search the phrase cloud computing on Google, you get tons of definitions, right? You get definitions on Wikipedia, you get definitions on many tech forums, right? So what I did was I just pulled in a few definitions from all these websites, right? So one website defines cloud computing as a general term for the delivery of hosted services over the net. That is, you have a bunch of services that are hosted over the internet, and many clients across the world can access these these services that are hosted somewhere centrally on the cloud. So it is a practice of using a network of remote servers hosted on the internet to store, manage, and process data. Right? So basically, you can have services that are deployed on the cloud that can be used to store, manage, and process the data. Right? So instead of having all this on a local server or a personal computer, or having it on premise, that is in your own location, you can have it on the cloud, and various clients across the globe can access these services. So moving on, plus another important factor is the third-party providers. Third-party providers like Amazon Web Services, Windows Azure, right, and many other third-party service providers are engaged in making this possible, right? So they have come up with various business models to make cloud computing possible, right? So what I'm going to cover today is I'm going to as I explained previously, I'm just going to define what cloud computing means, look at how cloud computing has evolved over the last few decades, come up with or explain the service models and the deployment models of cloud computing, and then look at the latest trends, right, of cloud computing, and see where we are and what we have in store in the future. So if you look at the cloud deployment models, there are three main deployment models, right? So one is the private cloud, the public cloud, and the hybrid cloud. Right? What private cloud means, as the name implies, is where you store, or basically you install the services on premise, and that is used only by one particular client. Let's come up with an example. That is, you have to develop your own online ordering website, right? That online ordering website can be used to dispatch orders to multiple vendors, such as Pizza Hut, maybe, or any other vendor, let's say in Sri Lanka. Right, so basically clients can log in to this website and basically place orders. One way of doing it is, as I explained, is the private cloud. This doesn't suit this particular scenario because the customers are across many regions. That is, one customer may be in Anuradhapura, the other customer may be in Colombo, right? So just think of a situation where you're hosting a web application that can be used by clients across the globe, right? So private cloud is not necessarily the solution there. So private cloud is basically where you host. There are two ways of doing it, right? One way is you set up your infrastructure on premise, that is in your local office, and you set up a machine or buy a physical server, and you install the services there, install the softwares there, and expose it internally. An ideal example may be the HR system, right, in an office, right? That is, the internal employees can use this particular service. That's one way of doing it, that's on premise. The other way of doing it is you can use a cloud service, but make sure that particular service is only accessible by a particular set of clients. So normally this is called single tenant application. That is, only one client uses most of the services that are deployed on a private cloud. Moving on, public cloud is completely the opposite as the image shows, right? So private cloud is within the building, say, right? Public cloud is completely different. You host it on somewhere else, right? Host it on the cloud, and that is accessible across the world. So usually different service providers or various service providers can be used for this purpose. For instance, if you look at Amazon Web Services, which is a cloud service provider, you can simply log into AWS, get yourself a service and expose it out. In the case of the first one, in the former, right, you get only the infrastructure. And I covered several examples as well, right? In the case of the latter, right, what happens is the service provider provides a platform allowing customers to develop, run and manage the applications, right? So previously we talked only about the infrastructure, but here it provides a platform allowing customers to develop, run and manage the applications without the complexity of building and maintaining the infrastructure. So what that simply means is you don't have to worry about the infrastructure. Some service provider provides me a platform, and what I have to do is I have to install my application on that platform. Right? That's in very simple terms, right? So what it does from a developer's perspective or from an engineering perspective is I can focus on my code and I can forget about the infrastructure to a certain extent, and I can use this platform, leverage it and deploy my applications, right? So let's look at some of the other examples that again provided by AWS, because I use AWS since I feel that it's again, like I said, leading when compared to the other service providers. So yes, so one such service is a relational database service, right? So previously I talked about having your database in a block storage or in your instance storage, right? You have to install it, you have to log in and install it, and you can have your application accessing it. In this case, what relational database service does is you have to worry less about it, right? So this provides a platform in which you can install your database services. So this guy stores, there are several database servers that are supported by RDS. One is MySQL, the other one is MS SQL, and there are other databases as well that are supported by RDS, right? So what it does is, what it helps you to do is you don't have to worry about going and installing MySQL or stuff like that, right? So you can rely on the RDS to do that. You have to simply go and say it's going to be, I need a MySQL server, and then your MySQL server will be installed for you. Further to that, it manages your scalability, availability, and scaling across regions. Basically, it ensures that there is no downtime and it's up and running, right? So you have a console on AWS where you can configure everything regarding the availability and stuff like that. So that is a platform for you, right? Previously we talked about infrastructure, right, where you have to install it. This gives you a platform on which you can install your applications. In this case, I took a database example because it's easier to explain in the case of my example as well. Another cool feature is the automatic load balancing and scaling. So like I previously said, right, so if you are getting hits, 1,000 hits per second, you would have to have 10 instances, right? Think about the cost, right? If you have 10 instances and only during the peak hour you get 1,000 hits per second, whereas in the off-peak time, if you're getting only about 5 hits, I mean, I'm paying for the whole day, right? I mean, there's no point. So what auto scaling does is, right? I'll explain. I'll come to load balancing as well. What auto scaling does is you can configure it, right? You can say that new instance should be spawned when the CPU utilization is greater than 20. And the number of maximum instance is 5 and the minimum is 2. So that sort of thing can be done again using, so it's another example of platform as a service. And in that scenario, so when you spawn new instances, obviously your the load balancer also should be configured in such a way that the new instances are automatically, the requests are routed to the new server, right? So now what you can do is you can deploy your online ordering application on 2 instances, right? And during the off-peak time or during the peak time, when there are so many hits that are coming in, it will start scaling, right? And then it will scale up to 6 instances and start supporting all the 1,000 hits. And after that, after the request count goes down, it will scale down so that you have to pay only for that duration, right? So that's another interesting feature. Is software as a service. This is basically you use, I think everyone uses this, right? There, I mean, there is no point, no point explaining it. So a software is hosted on the cloud and you use it, right? Basic examples, day-to-day examples, Google, Microsoft 365, Slack, Google applications, Facebook, DocuSign, things like that, right? Skype or whatever, right? So all the software that are hosted on the cloud and you use it over the internet, yes, it comes under this category. But if you look at the last one, right? So AWS also still plays a part, right? So AWS has moved from an IaaS provider to a platform provider, and now they provide the software itself. So examples are, for instance, the Elastic Cache. So it's pretty much similar to the RDS, but I would say it's a straightforward caching mechanism where you can cache your stuff, and there are other service software. So other softwares that are provided as a service by AWS as well. Okay, so that's pretty much the service models of cloud computing. So I'll be now moving into another area. So when businesses have been looking at IaaS, platform as a service, or software as a service, other businesses or some businesses have looked at it from a more holistic approach, right? So what they have done is they have come up with various different business models, right? So one such model is cloud consultancy, right? So I thought of touching this as well, since I thought this is pretty interesting, right? So if look at it, this is a screenshot of their website. So what they do is they help you to manage your cloud cost, help you to optimize your cloud cost, right? So what they do is they play a role of consultancy in managing your cloud services, right? Say you are a startup. Say my online ordering web application is a startup, right? So I don't know which cloud service to use, right? So what these guys are doing is they have come up with a business model. There are so many guys like this guy, right? So, and what they do is they make sure that you select the correct cloud service provider, you select the correct platform if it's a PaaS, or if you select the correct software, right? And they play a role in consultancy. So if you look at it, they support a large number of cloud service providers. They are not, they go across all these cloud services. So if you prefer Microsoft Azure, or if you prefer Rackspace, for instance, I know no one prefers Rackspace in these days, but yeah. So then you can these guys play a role in cloud consultancy, right? So they have moved ahead, right? They are looking at it from a total different angle, and trying to get some bucks right out of it, and they're pretty rich companies, right? So that's one way of doing things, right? So this is also I thought of including it because it has been a trend over the last 5 to 6 years, or even more than that. The other guys, what they do is they provide miscellaneous services. Now just imagine I need to send out an SMS, I need to send out an email, or I need to manage my logs in a cloud service, or I had to do different various stuff, right? So what the other guys do is they help us to live more easily and sleep more easily, and they look after all these stuff. For instance, Grafana is an application that helps us to monitor what's happening. For instance, you can have a metrics dashboard to see how your servers are increasing. Actually, AWS has it on its own, but if you're installing on a different maybe on a private cloud or so, then you can use tools like Grafana to do your metrics evaluation and stuff like that, right? So I just added this as well. So various add-on providers for email, storage, messaging, monitoring, and logging, right? Okay, moving on with cloud, right? So I talked about IaaS, I talked about PaaS, I talked about SaaS, I talked about the different business models, or the companies that have come into the picture, doing various different services like consultancy and stuff like that, right? So I'm just going to mention containerization because I think it is a key point, or it has changed this cloud computing concept altogether. But having said that, containerization is a topic on its own. I can speak 2 to 3 hours on containerization itself, right? So I'm not going to go into depth. What I just want to say is this has changed. This has changed a lot of things in cloud computing. Previously, you talked about virtual servers. I mentioned virtualization, right? That is where you have one physical storage, and then you install some sort of a virtual software, and then you have virtual servers on top of top of that physical machine, right? In the case of containerization, as this definition says, a container image is a lightweight, standalone, executable package of a piece of software that includes everything needed to run it. So basically, everything's on that container image, right? So if you have the container image, you can basically run your software. So that's what it says, right? Unlike VMs, containers do not bundle a full operating system. So that's the main difference, right? So you don't need a full operating system to run your container, right? So when we were working in our projects, right, at that campus, what we did was, right, we have a VM. So if you have a Linux, you may install something like Oracle VM or Oracle VirtualBox, and you install a virtual image, and then you spawn it up, and that's pretty much virtualization, right? What containerization does is, right, so in that case, the hypervisor was there. Hypervisor is your VirtualBox, right? It's a software that manages it. Right? So if you look at virtualization, you have the infrastructure, you have the host operating system, you have a hypervisor. And then you have the guest OS. Say you are installing Windows VirtualBox on top of Linux, then your Windows will be your guest OS, and so on and so forth. Here the main difference, right, there are so many differences. The main difference is you have the operating system and you have something called a Docker engine. Docker is not the only containerization thing out there, but then a lot of people think that Docker is containerization, but it's not. There are other providers as well. But let me say, so what Docker does is it replaces the hypervisor, and all these containers are deployed independently. Remember, it's a small piece of software that can exist on its own, right? So the containers are deployed on top of it. So containerization eliminates all of the baggage of virtualization by getting rid of the hypervisor and all the VMs. So it's lightweight, yes, and it has enabled us to push out, for instance, if you have a container image, you can push it to a Docker hub, right? And then when deploying it, you can pull the image from the Docker hub and then deploy it in your instance, right? So just like virtualization, one single physical machine can be used to support multiple containers, just like it, but it's more lightweight, right? There are a lot of differences. Just read through it, but I thought of mentioning it since it has played a major role in cloud computing evolution, right, and cloud computing trends, right? So moving on, yes, now we talked about containers, and so there is this way of putting out images, creating containers and putting it across in the cloud, and when we are deploying it, you pull the images from the cloud and then you spawn the instance. So that's, let's say that's containerizing, let's say that's not, but yeah, you can do that, right? So what AWS has done is, and actually basically I have mentioned AWS almost all my slides because they have almost leveraged almost all the stuff that I talked about, right? So what they have done is they have come up with Elastic Beanstalk, right? So what you can do is you can simply upload the Docker file, right, to the Elastic Beanstalk Beanstalk platform, let's say, right? And Elastic Beanstalk will look after pulling the Docker image and starting up the applications using a Docker file instructions and so on and so forth, and you can easily spawn up a new instance based on a new container. That is basically you can start up an instance which has a container on it and the application runs on top of it, right? So similarly, AWS Elastic Container Service has gone a bit ahead, right? They talk about managing clustering, managing a large cluster. So imagine your online ordering website grows into a global thing, and people start ordering from everywhere. Then you can use Elastic Container Service, which supports clustering and supports. So what I wanted to say was containerization has made a major change in this cloud evolution. Okay. So if you look at the previous diagram or the what you call the pyramid I showed, so I had software as a service, infrastructure as a service, and platform as a service, and then software as a service. But here, what I've drawn is, so previously, historically, virtualization was a big hole, right? So virtual machines and all that, and then platform as a service, where different service providers provided platforms, right, so that you can leverage it and deploy your applications. And then came containerization, and Docker leveraged it a great deal, the concept of containerization, and then you can have Docker images posted on the cloud, and then you can pull it up and install. The latest trend is serverless computing, right? Serverless computing. So anyone, what does what does the word serverless mean to you? I mean, I talked about these stuff. Anyone? I just need an answer, right? So someone has to talk about, otherwise I'm not going to proceed. Anyone? When you say serverless, what does it mean? Sorry? Okay, that's what it means, right? So basically it means there is no server. I mean, there is no server at all. But what it actually means is, right, there is a server, but we don't have to really worry about it, right? So some guy, he comes in and he worries about the server, right? And there is no server. I don't care whether there is a server. I have to worry about only my development. I have to worry about only my stuff that I'm doing day to day. What serverless computing is all about is you can completely forget about infrastructure and scaling, right? Engineers care only about the code, while the DevOps guys care only about the pipeline, right? So what a DevOps engineer will have to do is, they are not going to go out of work. So what they have to do is, right, so they will be looking at the pipeline, right? How is the application that is deployed on the dev environment go into staging, go into production, right? So that will be their job. I mean, because we don't have, I mean, we have infrastructure, but we completely forget about it, right? So someone else manages it for us, right? So another interesting point is it's pay by execution, right? You don't have to pay when your servers are idle, right? So what you have to do is, for instance, in the online ordering website that we have created, say you have to run a scheduler, right? So I don't have to pay for a scheduler service completely because the scheduler runs only daily, let's say, right? Say I need to push whatever, right? I just need to notify customers daily, that vendors daily, that I have received this much of online ordering, the count of online ordering daily, right? So what we can do is, for an example like that, you know, pay by execution model suits the purpose, right? Because you have to pay only for the time the scheduler runs, right? You don't care when the scheduler is not running. So that's another important key factor in the case of serverless. And then of course event driven. I'll explain event driven in a later phase. And it's an ideal fit to microservices. I wanted to mention microservice because it's again another key factor in the trend of cloud computing. So historically, when you develop an application, let's say I need a backend API, right? API for my online ordering website, right? You put everything together, right? That is, for instance, in the case of online ordering, there can be APIs to push to place orders. That is, the web application calls the API to push the order to the vendor, right? And there can be APIs on the same component that manages the vendors, right? So for instance, the vendors can register himself on the online website using these APIs. So it's a mixture of everything, right? So it's together, right? So that's what we call a monolithic application. I would say monolithic applications are major, right? So I took only two. I mean, just wanted to explain now. Yeah, I mean, explain using an example, right? So what a monolithic application is, it puts all its functionality into a single process, right? So everything's together. Whereas in the case of microservice architecture, you will rather put it to separate services, right? So as this microservice architecture puts each element of functionality into a separate service. Why I wanted to touch microservice in the case of serverless computing is, just imagine, right? I break all my monolithic, my online ordering API into 3 applications, right? I have to deploy all of these individually. I have to look after all the infrastructure individually. But since serverless computing does not have infrastructure, or it's serverless, right? I don't have to worry about it. So I just have to, deploy it in some sort of a service, I presume, and then I can forget about infrastructure, and then I can do this. Microservices has a lot of advantages, right? For instance, if you deploy it independently, I'm just giving a couple of advantages. So you can deploy this green guy without disturbing the orange guy, right? So for instance, you can deploy the release for this green guy without this way, but in this case, you have to deploy the whole thing, right? So you have to test the whole thing, right? And it will take time to production, and the time to production is going to be high. So in this case, advantages like that are there. So with serverless computing, it's an ideal fit for microservices, right? As they say, right? As a lot of documents say, right? So moving on, serverless providers. So there are different serverless providers. One is AWS Lambda, Azure Functions, Google Cloud Functions, and IBM OpenDisk. they have their own sort of serverless software or platforms that are available. So, and some of these guys, if I remember right, I think it was Azure, right? They call it as a function, right? So remember platform as a service, sorry, infrastructure as a service, platform as a service, software. Now they call it a function as a service, right? So these guys call it a function, right? So these are some of the famous serverless providers out there. So we have moved from infrastructure as a service to a service model where there is no infrastructure at all. IAM is identity and access management. So let's say IAM is sort of a web service that is hosted on AWS itself, right? So you can use IAM service, let's say, right, and then restrict access to certain resources, right, within AWS, and you can also leverage it to use it to restrict access to other services as well. Right, so I'm just going to have it as open. Click on next. Okay, so since I have used a template, right, I have been given this, right, not exactly actually. So I had to give a name to my function. So let's say get restaurants. Then it asks for the runtime. Right, so it supports several runtimes, so Java 8, Nodejs, versions, Python and all that, so I'll just select Nodejs, right, and then scroll down. So what really happens is, so when a client triggers this particular endpoint that I'm going to build, right, it's going to trigger this exports.handler method, or the call, or the method rather, right, so what it does, I'm not going to go through the code in depth, but so what it does is it checks for the HTTP method, right? So it can be get, put, post options or whatever. So but here it supports for delete, get, post, put and all that. And then in the case of get, it will just scan the Dynamo. I'll explain the DynamoDB in a bit, right? And then I'll just leave everything as is. Move down. So then you have to define the permissions of your Lambda, or for your Lambda rather, right? That is, this role, right, this section role defines the ability or the security or the, or what you call the authorities the Lambda function has, right? Whether the Lambda function can access an S3 bucket, whether the Lambda function can access an external resource, something like that, right? So what for now what I'm going to do is I'm just going to select an existing role. I'm going to just select Lambda full execution, which I created just before the presentation, otherwise it will take time. So it has a, I'll come to that again, so I'll just revisit that in a bit. And then you can click on tags and you can enter tag if you like, and then advanced settings. So in advanced settings, right, what you can do is you can set up your memory. Now remember, right, your serverless, right, you won't be able to see the server after this whole thing is done. So now you have to specify the amount of memory, the timeout period, right? For the DLQ resource, this particular one, what this does is you can, if you basically, if the maximum retries of the API, for instance, if the API fails and it's been retrying or somewhat also, right? You can select a resource, and this is basically the simple, I can't exactly remember, this one simple queue service, right? You can dispatch an event to the queue and you can listen to the queue and get that event. So it's basically event driven. So if something drastically goes wrong and some client has exceeded maximum retries, then you will be getting you can configure it to get an event via the SQS, things like that. And then you can configure the VPC, like I mentioned earlier, virtual private cloud, right? You can have all your instances in a private cloud. Similarly, your AWS can be restricted to a VPC. Again, I'm not going to do anything right now, but it's possible, right? And then the KMS key, that is, if you have any environment variables or any information that needs to be encrypted, right? The KMS is a key management service by AWS, right? So it will manage your keys and make sure it's all encrypted, right? So I'm just going to click on next, and it just gives me a summary again. So I'm just going to click create function. So at this stage, I have created a Lambda service, right, with this particular code, right? And I need now, I mean, I haven't talked about the client. I haven't talked about the way a client triggers the Lambda, but I have a Lambda now. I have a Lambda service. I have exposed my function guest restaurants as a service, right? So with this, I can test my service, right? So let's say, so remember, it supports both. Okay, let's change it for an easy thing so that I can explain. Let's say done is a function above, right? So I'll just type hello world here, right? So I've just edited the get case here in the switch statement to return a hello world message. I'll just remove this for now, right? And I can save it again, so I can do any changes I like to the code, right? Save it and then test it. So when I'm going to remember, right? So this is a template. Remember, these are all templates. You can all configure this, right? But I can't go into depth with the time I have. But you can all change this. You can change this, right? And now I need to trigger the get event, right? One small problem with this is I can't scroll down. I mean, it's a bug on AWS. So what I'm going to do is I'm just going to cut all this and paste again. Then I can scroll down, I think. Hopefully. No, I can't. No, I can't. I don't know. It's a bug. Let me check again. So let me copy that to a file here. Probably it's an issue with Chrome. I don't really know. So basically what I'm going to do is I'm going to change one of the variables, the HTTP method. I can even show that. So this is a body, right? It looks a bit cryptic here, but I'm going to just change it to get, right? So I'm just going to copy it back. Let's save and test. Hopefully it works. Yeah. So yes, right. So now remember, right? The get method, I did a small change to return hello world, right? So now I have a Lambda service that supports get HTTP method, and it returns me a text hello world, right? So that's a lot of things, right? I mean, it's deployed now on the cloud basically as a Lambda service, right? So what else can I do, right? So what can I do more is, so yeah, this was a configuration tab I previously explained, and you have monitoring, right? So all your logs will be on CloudWatch, right? That again provided by AWS, right? And right, so you have all the logs in this manner, right? So you have the log. So if someone, I mean, everything is accessible, right, via the console. And you have all the durations, the hits, and so on and so forth, right? So now what I'm going to do is, now I need a way for a client to access this particular API, right? So I'm going to go to my triggers. So what it has done is it has automatically integrated or added a connection with the API gateway, again a service provided by AWS. So what API gateway does is, as the name implies, it's a gateway for your APIs, right? For the API gateway will sit in between the APIs as well as the clients, right? And then it will manage the authorization, manage the routing, maybe some sort of maybe if you want to restrict, maybe throttling, right? If you want to restrict the number of hits per second, stuff like that. So API gateway does that for you, right? So it has already, you know, integrated or added an integration with the API gateway. So let me click on that link. Right, so it has added some sort of an integration, and here I can click create method. Now what I want to do is expose a get, right? Remember, I exposed only a get. Click on it, just select that method, and I entered it as get, and then I can add an integration type, right? So I have to integrate this particular AWS endpoint, API gateway endpoint, resource, I should say, resource to the Lambda function. Right, I'm just going to tick this as well because it makes my example a lot easier, but you can go without ticking that, then I have to manually configure a lot of things, right? So and the Lambda region is, since yeah, so it's UAC is 2, and my Lambda function is I can get restaurants, right? And I'm going to save. So it's just going to ask me, so you're about to give API gateway permission to invoke your Lambda function, right? So I'm just going to click on that as well. Basically the API gateway now can call your Lambda function. So then it gives us a diagram, right? So what it says is, this is the client. Through the method request is basically, let's say, the API gateway. So this is inside API gateway, and then the integration request, and it goes down to Lambda, integration response, method response, and it comes back to the client. So if we used a different proxy sort of integration, previously I ticked the default one, you can even map the response to something else, right? So now you have an endpoint, a resource that's integrated to Lambda, right? Now what I have to do is I have to just deploy it. Simple, right? I just deploy it. So I can add the deployment stage as dev and something, and then I can just click on deploy. So what it has done is it has deployed it, and basically the Lambda was already deployed. The API gateway resource has been deployed, integrated to the Lambda, right? So you're done. Basically your API is now on the cloud, right? So that's where serverless comes in, right? You don't care where the server is, right? Server is gone, right? So what you can do is, apart from all that, right, you can even, there are so many features, right? You can enable throttling, you can, maybe add a client certificate, enable cloud watches and stuff like that, and then you can even export your API documentation as a Swagger document so that you can share it. So Swagger is a tool for API documentation, so you can easily expose that documentation as Swagger, and you can use that API doc JSON on Swagger providers as well. Deployment history, and I'm not going to go into this. So let me go into this. So this is my right. So my resources, remember, my resources get restaurant. So this is my endpoint. Ideally should work. So let's see. Yeah, so I get the hello world response. So basically it has gone through to AWS Lambda, my function as a service, and then returned the response. So I can just, right, so what I'm going to do next is I'm just going to integrate this Lambda service to DynamoDB. So DynamoDB is, just to conclude the presentation, so what I did was I talked about all the deployment models, the service models, and the latest trends in all this stuff, and then I talked about serverless computing, which is a big buzzword, right? So cloud computing is definitely a big buzzword if you look at the last few decades, right? So we have moved a lot, right? I mean, we are the generation that that has gone through this a lot, right? If you, up to now, right? So probably our children one day will go through this transition phase even more quickly, right? So it's what I would say, and what all writers say, it's just a start, right? There's a massive future around there, and what we have to do as engineers is to focus on your applications more, at least, right? And focus less on your infrastructure, and make sure your applications are written in a more efficient manner instead of focusing on everything, right? So all these cloud services, all these cloud service providers help us to do this. However, we have to focus on the fit, right? That is, whether this particular service fits your application. I mean, we should not just do it just for the hype, right? So we should make sure whether the AWS Lambda fits your application. We should not just blindly go and do it, because it might not. For instance, an enterprise service bus deployed on an Lambda service might be even more expensive than a separate EC2 instance. Because if you look at an enterprise, it might be getting a lot of requests, right? I mean, we won't have a major advantage. We might not have a major advantage hosting it on a AWS Lambda service. So I just took this from Rabindranath Tagore, right? So what he has said is, clouds come floating into my life no longer to carry rain or storm, but to add color to my sunset sky, right? So definitely cloud computing adds a lot of color to the work we do day to day, right? A lot of color. This is not about cloud computing, but this fits nicely into cloud computing, right? So it no longer carries rain, that's a different story, but it adds a lot of color to the work we do and makes our lives a lot easier. So we have to leverage all these service providers or all the functions, the services provided by these guys, and use it as much as possible. So that's pretty much it, right? So I hope you gained something out of my presentation, and my colleague will follow suit soon after with another one as well.